The last section in chapter 11, we have to look at proportions. So like in chapter 9 and 10, we looked at one proportion. So we did like a 1 proportion z interval, a 1 proportion z test. Now we're going to do 2. The reason proportions are second, whereas usually they're first, is because they get a little bit more complicated. So you're going to need to know, again, 2 sample sizes. They do not have to be the same sample size. Okay, that's really not important. You're going to have P1 and P2. Those would be the population proportion of each. And then you're going to have P hat 1, P hat 2. So the sampling distribution of P hat 1 minus P hat 2. For the mean, just subtract the population proportions, P1 minus P2. Now, variance and standard deviation, we're going to skip variance because you don't really need to know it. The standard deviation is tricky. It's the square root P1, 1 minus P1 over N1 plus P2, 1 minus P2 over N2. This is written on your formula sheet. It's basically the standard deviation that you had for chapters 9 and 10, but doubled. 9 and 10, you just did P1 minus 1 minus P1 over N. You just did this part. But now that we have 2 proportions, you got to do it twice. So it is at the, right here, difference of sample proportions. Now, there's this weird thing in proportions when we do testing called P sub C. It's the combined proportion. So all the combined proportion is x1 plus x2 divided by n1 plus n2. So it's basically the total number of successes over the total of the 2 samples, of two sample sizes. Okay, you're going to have to use P sub C when we do hypothesis testing. That's going to end up being your denominator. So you got to combine them. And the reason that we do that is because you've got to think about, we've always talked about bigger sample size means better, more accurate answers. That's all we're doing is we're combining the samples. It's like a weighted average. Okay, so you don't actually use this one. We use P sub C more. And I'll get to that in a minute. So how do you do a write-up? Just like everything else. Condition 1, we're going back to independence. So 2 random samples, they should be independently selected. Now, condition 2 is just always the pain. You have to check both n times p hat 1, n times 1 minus p hat 1, and n2. So you have to check both samples 2 things. So you're going to give me 4 numbers for condition 2. P hat, so like you're only going to look at the sample. Or you can have sampling distributions that are approximately normal. So this is a 2 proportion Z test. Remember, proportions are never T's. And then condition 4, you have to basically tell me which one's P1 and which one's P2. Now your null hypothesis, just like with the means, it's either P1 minus P2 is 0. I prefer to write it that P1 and P2 are equal. And then your alternate can be P1 not equal to P2, P1's greater than P2, or P1's less than P2. She didn't give you a pass?
I said I'd talk to you, so I was just like...
Okay, so the test statistic is P hat 1 minus P hat 2. Notice the difference here. We have to use P sub C for our denominator, because we won't have a hypothesized value. And we don't know the true population parameters. So instead of using P hat 1, P hat 2, you use P sub C. On your calculator, you're going to use 2 prop Z test. This is test number 6. So in the calculator, this is test number 6, 2 proportion Z test. So the only tricky part about 2 proportion tests is you got to remember to do P sub C. Okay, but the good thing is the calculator does give that to you. So you don't necessarily have to do it on your own. Okay, so we got 2 examples to go through. So a group of college students were asked what they thought the issue of the day was. Without a pause, the class, almost to a person, said student retention. Then the class went out and obtained a random sample and asked the question, do you plan on returning next year? The responses along with the gender of the person are summarized in the table below. Test to see if the proportion of students planning on returning is the same for both genders at the 0.05 level of significance. So you can tell it's a proportion because there's obviously no mean, no standard deviation. We're just going to be looking at, this is like x1, x2, our totals. We got to figure out the total. For males is 275. For females is 182. So we're going to need that. This is N1, N2. Sometimes, just like we did in Chapter 9 and 10, they'll give you the percentage, and sometimes they'll give you the numbers like this. Okay, so for our conditions, condition 1, we have independently selected random samples. Right, because they said they went out and asked random people, and then the gender would make the 2 things independent. Okay, so I got to check both n times p hat 1 and n times 1 minus p hat 1. So really it's the number of successes. So it's 211 is greater than 10 for the males. And those who said no or maybe, 64 is greater than 10 for the males. So this is like the success, the failure. For the females, you have 141 is greater than 10, and 32 and 9 would make 41 greater than 10. So I'm okay because you have to do 4 things, especially this kind of table where you have the numbers. Just give me the numbers. Okay, you don't necessarily have to write out N1 times P hat 1 and like that, because you got to check 4 things. So therefore, our sampling distribution is approximately normal by the central limit theorem. The good news is for proportions, you don't ever have to do box plot. This is as difficult as it gets. So here we're going to do a 2 proportion Z test. Now you can stick with P1, P2, or I'm going to do PM and PF. So PM is the true proportion of males returning next year. PF will be the true proportion of females returning next year. So for the testing section, we're looking at if the proportion of students is the same for both genders. So PM is equal to PF. So my alternate is just that they're going to be not equal. So two-tailed test. And you're going to have a Z and a Z. Okay, so for our test statistic, to write it out, it's actually probably easier since we don't have, let's do it in the calculator, and then we'll write out all of our stuff. Because all I need for you to give me for the testing is we need p hat for the males. Oh, test statistic. Thank you. P hat for the men, p hat for the females. Well, and then we got to give, let's do it in the calculator first. So 2 proportion z test. So when it asks you for in the test, it does not want percentages. So if I give you percentages like 70%, 30%, you got to convert to whole numbers. So here, this one's fine, so we're good. So 211 out of 275 for the males. 141 out of 182 for the females. Now, this is another one where it's helpful, just like with paired, to hit calculate rather than draw. Because then it'll spit everything back out. So there's your z-score, your p-value. So p hat for the men was 0.767. For females was 0.775. See this just regular p hat? That's p sub c. That's p sub c. So 0.77. So you're going to need that because our formula, there's no degrees of freedom here. Our alpha is 0.05. You can say n for the males was 275 and n for the females was 182. So then our z, bless you, is 0.767 minus 0.775 divided by, now use p sub c, 0.77.23 over 275 plus 0.77 times 0.23 over 182. So whenever you do a 2 proportion, that's why they give you 3 p hats here. P hat 1, p hat 2, that one's the combined. You use the combined in the denominator. So this equals negative 0.185. So here we'll have a negative 0.185 and positive 0.185. Then if we write out our sentence, a z value of negative 0.185 gives us a p value of 0.852. So you just got to be careful with this kind of stuff. There's a lot of p's going on. P hat 1, p hat 2, p sub c, and the p value.
Should we put plus or minus 0.185?
You can if you want. You don't have to. Okay, so our conclusion. Is this lower than our alpha? No. So we're going to have to fail to reject. So it looks like the proportion is the same. So since the p-value is greater than our alpha, we have evidence to fail to reject the claim that the true proportion of students returning next year is the same for both genders. And then you basically, when you fail to reject, you kind of rewrite it for the second sentence. Bless you. It appears there is an equal proportion of males and females returning. Okay, questions? Like I said, you don't really need to know this until the test. It's not on the quiz. But it's weird because you got to use P sub C. It's something different that we've never really done. You do have to give me P sub C. It's really, if you think about it, it's like 211 plus 141 over 275 plus 182. So that all I'm doing is combining to make one big sample. And that's what that percentage is.
Do you have to write out the PCC for me?
No, as long as you give it to me, you're fine. Okay. Want to try one more? Sure. Okay. This one's nice because it has both, and we're going to go NS, NF, or U. It has both the sample sizes, the X's, and the p-hats. So sometimes I give you all three. So a consumer agency spokesman stated that he thought the proportion of households having a washing machine was higher for suburban households than for urban. To test to see if the statement was correct at the 0.05 level of significance, a reporter randomly selected a number of households in both suburban and urban environments and obtained the following data. So here's the number of houses they went to, number of people who had washing machines, and the proportions. Okay, so for our conditions, you have independently selected random samples. Again, they're not really going to ever use the word independent, but they're coming from two different types of environments, right? Suburban and urban. So that's that independent. Okay, so we got to look at the proportion of success and failure for each one. So for suburban, we have 243, that's greater than 10. And if I do 300 minus 243, that's 57 is greater than 10. And then you got 181 is greater than 10 for the urban. 69 is greater than 10. So it is kind of nice when they give you X as opposed to just giving you this. Otherwise, then you got to do some multiplication. So therefore, we can assume both sampling distributions are approximately normal by the central limit theorem. So we're doing a 2 proportion Z test. So P sub S is going to be the true proportion of suburban households with a washing machine. And P sub U will be the true proportion of urban households with a washing machine. So for our testing, The null hypothesis is that the two proportions are equal. The alternate, you got to look at the question. It's saying the proportion of households with a washing machine was higher for suburban than for urban. So we want P sub S to be greater than P sub U. So this is a one-tailed right, because we're going to look at greater than. So when I do my test statistic, you don't have to give me everything in the table. You don't have to give me the x's. But you know n of s was 300. P hat of s is 0.81. N for urban was 250. P hat for the urban was 0.724. Alpha's 0.05. And then our P sub c, if you wanted to figure it out, it's just 243 plus 181 divided by 300 plus 250. Now you can just have the calculator do it if you want. So 0.77 again. It's weird that it's the same for both. So you can either do it this way where you show some work and do it on your own, or you can just use a calculator. Yes. You want to do P hat 1 over P hat 2 times what?
No, P hat 1 over P hat 2 over
No, it's a weighted average. Did you get 0.77?
Yeah.
Then you're fine. So Z is 0.81 minus 0.724 over 0.77 times 0.23 over 300 plus 0.77 times 0.23 over 250. Now I got to use the calculator. I mean, you can do the math if you want. Again, it should give you, so P hat 1, P hat 2, P sub C. So here our Z value is 2.39. And we get a P of 0.0084. So a Z value of 2.39 gives us a P value of 0.0084. So is this lower than our alpha? Yes. So now we're going to reject. Since our p-value is less than our alpha, we have evidence to reject the claim that the true proportion of washing machines is the same for urban and suburban households. So we're rejecting the null hypothesis, so we're going with the alternate. It appears a larger proportion of suburban households have a washing machine. Okay. Questions?